I want to show you how to find an inverse function. I'm going to do the example f of x is equal to x squared minus 1, and this is for x greater than or equal to 0. Let's take a look at why we've restricted the domain to x greater than or equal to 0. Here's the graph of x squared minus 1 without a domain restriction. So looking at this in terms of it just being a function, it definitely passes the vertical line test. But unfortunately, this function is not one-to-one. We know that because there is such a thing called a horizontal line test. So if a horizontal line hits that function more than once, then that means it's not one-to-one. And if it's not one-to-one, an inverse doesn't exist. So now let's look at that restriction. So the domain restricted to x greater than or equal to 0. So notice that the graph is cut off right here at x equals 0. So we've taken out the left part of it. So all we're left with is this point, which should be a point, all the way up. Now if you can imagine the horizontal line test, any horizontal line will pass through this graph only one time, at most one time. So that means it's one-to-one. So now we can find our inverse. We'll get back to the graph here in just a minute. I want to look at this algebraically. Let's find that inverse algebraically using these 4 steps. The first thing to do is to just put some notation in there that's a little bit different. Instead of having f of x, which makes it a bit confusing, let's throw y in there instead. The second step is to switch x and y. Then we can solve for y in the third step, which will give us our inverse. The last thing we need to do is get that function notation back in there. So for the fourth step, instead of y, let's put in f inverse of x. Okay, so here we go with our example. The first step, throw y in there. So we have y is equal to x squared minus 1. Second step, switch x and y. Make sure that square stays on the y and doesn't carry over to the x. The third step, solve for y. This is usually the tricky part. So for this example, it's pretty straightforward. Start by adding 1 to both sides of the equation, and then we can take the square root of both sides to get y by itself. Now notice that I didn't put plus or minus in front of the root, which is usually what we do when we take a root. But in this case, if I do that, I wouldn't have a function. All right, so now for the fourth step, let's put that function notation in. So we have f inverse of x is the square root of x plus 1. Okay, so now let's get back to graphing. What I did is I put the original function f of x, which is in red, and the inverse function, f inverse of x, in blue. All right, so remember what I said about not wanting a plus or minus in front of the square root for the inverse. Okay, so here we have our square root of x plus 1. If I had a negative square root of x plus 1, it would go down here. So it would look like a parabola that's on its side. Now, if I did include that piece, it wouldn't be a function because it wouldn't pass the vertical line test. Okay, so that's why I definitely don't want that minus out in front. All right, so now let's go up here and look at this. I have y equals x, which is this straight line right here, this black one. Obviously it's straight because it's a line. And the reason why I put that there is because whenever you have a function and its inverse, they are symmetric about the line y equals x. And you can see that. There's a mirror image over that line. The last thing I want to do is find domain and range for f and the inverse. All right, so we know what the domain is. 0 to infinity, including 0. So we know that because it was given, and looking at the graph, it's everything on the right side, including that point. Now, the range of f. So we can see, remember range is y values, we can see that the smallest y value lands right here at -1. Notice that this is -2 down here. So this isn't -1, it's right here. Okay, so from -1 on up to infinity, those are where our y values occur. So that's why we have -1 to infinity as our range. Okay, so if we look at the domain and range of the inverse, remember that's the blue one here, the domain goes from -1 to infinity. The range, starting right here, for the y values, goes from 0 off to infinity. Now, do you see something going on here? We see some similarities, right? So the domain of f of x is exactly the same as the range of the inverse. Now, of course, domain means x values and range means y values, but when we write this in interval notation, they're exactly the same. So similarly, the range of f is going to be the domain of the inverse. And that's always going to be true when you're talking about inverse functions. And I think that's about it for this example. Thanks for listening.